So we will go through electrical work, electrical power and electrical energy today. So first let us see what is electrical work. So you know, in an electrical circuit, usually the movement of electrons, that is nothing but the transfer of charge, is called as electric current. So electric work is done when there is transfer of charges. So unit of work is called is the unit of work is joules. So electric work is given by W. So V into Q joules. So where V is voltage, Q is the charge. Now you already also know that I can write current I is equal to Q by T. So from this I can also write electric work W as V into I into T joules. So where T is the time in seconds. Next is electric power. So rate at which the electrical work is done in an electric circuit is called as electric power. So rate at which electrical work is done. In an electric circuit is called as electric power. So electric power P is given by electrical work by time. So you know already electrical work is nothing but it is given by W divided by time T. So what is W? W is V into I into T divided by T. So electric power P is given by V into I. So this can also be written as P is equal to V into I, or you can also write it as I square R, or you can write it as V square by R. That is by substituting I is equal to V by R, or you can substitute V is equal to I into R. So that is, so if you substitute V is equal to V into I, in this if you substitute V, that is I into R into I, you will get I square R. Suppose in this if you substitute P equal to VI, so in this if you substitute V into I, that is V by R, you will get V square by R. So these are the another formulas for your electric power. So electric power unit is given in watts. Next, electrical energy. So electrical energy is the total amount of electrical work done in an electrical circuit. So this gives you the total amount of electrical work done. In an electrical circuit. So E is equal to V into I into T joules. So this one will give you electrical energy. So let us solve the problems. So we'll see how to use this electrical power equations and your electrical energy equation or your electrical work equation in the problems. So the first problem, so first thing that you have to find out is what is the power developed by the resistor. So you know you have got equation for power P is equal to V into I, or you can use I square R, or you can also use V square by R. Now in your question they have given you the current and they have given you the resistive value. So let me use P is equal to I square R equation. So you have 4 square into 10. So this one will give you the power developed by the resistor. So 4 square into 10. So this one will give you 160 watts. So this is the answer for the first one. Next, they have asked you to calculate what is the energy dissipated in 3 minutes. So E is equal to V into I into T joules. So E is equal to, or your energy dissipated, that is nothing but your work done itself. So E is equal to V into I into T joules. So V you don't know. So what I'll do is I'll use another formula, that is what is V into I. V into I, so I can also write it as E is equal to V into I into T joules. I can also write it as I square R into T. Why? Because you know what is V into I. V into I is nothing but power. Now power can also be written as I square R. So I have written I square R into T. So I can substitute that. So 4 square into R is 10 into time. Now time is given in minutes, but according to this formula time is in seconds. So I have to write the time in seconds. So if it is in seconds, it will be 3 minutes into 60 seconds. So this one will give me the energy dissipated in 3 minutes. So 4 square into 10 into 3 into 60. So you will get 28800 joules. So this is how we are going to solve the problem. So let me take a next problem. So they have given you a 250 volt lamp is rated to pass a current of 0.3 amps. So voltage is 250, the current is 0.3. So you have to find the power output. So let me first solve the first part of the question. So first they have asked you to solve the find out the power output. So you can see P is equal to V into I. So P is equal to V into I. You know the voltage, that is 250. You know what is the current, 0.3. So you can find out the power. So 75 watts. Next, in your question, they asked you, the next question was, if a second similar lamp is connected in parallel with the first lamp, find the supply current required to give the same power output in each lamp. So they have told you another set of lamp is connected with the previous set of lamp in parallel, and you have to find out what is the supply current. So you have to find out what is supply current. And they have also said you that the second set of similar lamp which is connected in parallel also gives the same power output as the previous one. So let me calculate the total power output. So total power output, I can say it is 75 plus 75. Why? Because they have told you in your question clearly that the second set of lamp which is connected in parallel gives you the same power output as the previous one. So 75 watt plus 75 watt. So that one will give you 150 watt. Now what I have to find out is I have to find out what is the supply current. So I will use this equation, P is equal to V into I. So from this I is equal to P by V. So now I know what is the power when two set of lamps are connected in parallel. So that is nothing but 150 divided by V. V is nothing but the voltage. So voltage is given in your problem as 250. So 150 by 250. So you will get an answer of 0.6 amps. So this is how you are going to solve the problem. So let us go to the next question. So first what I'll do is I'll draw the circuit. So they will not give you the circuit at all time, every time. So first let me draw the circuit. Now they have told you have two parallel resistors having resistances of 20 ohm and 30 ohm. So let me draw two resistors, that is 20 ohm and 30 ohm, connected in series with 15 ohm. So this is connected in series with 15 ohm. So it is connected to a supply. Let me take this as B. So they have told you the current through 15 ohm resistor is 3 amps. So 15 ohm resistor current is 3 amps. So you can say this is the main current. I is equal to 3 amps. Now you have to find out first, you have to find out is current in 20 ohm and 30 ohm resistor. So how can I find out this? So you can use your current divider rule. So if you see, if you remember your current divider rule, that is I1 is equal to I into R2 divided by R1 plus R2. Similarly, I2 is equal to I into R1 divided by R1 plus R2. So let me take this current that is flowing in 20 ohm resistor as I1, current that is flowing in 30 ohm resistor as I2. So first let me find out what is the current flowing through 20 ohm resistor. Now you already know what is the main current that is flowing in the circuit, right? So the main current flows until here. From here it gets divided into I1 and I2. Now main current is 3 amps into the resistor in another branch. Resistor in another branch is 30 ohm divided by 20 plus 30. So this one will give you the first answer, that is the main current. So I1 you will get as I1 you will get it as 1.8 amps. Now next you have to find out I2. Now you can also use this equation, or you also know this equation, that is I enters inside and I1 and I2 leave, right? So you can also say I is equal to I1 plus I2. I you already know that is 3 amps. It is already given in your problem. 3 is equal to I1 you have found out 1.8 plus I2. So what will be I2? I2 is equal to 3 minus 1.8. So I2 will be equal to 1.2 amps. So you have already found out the current in 20 ohm and 30 ohm resistors. So the first question is solved. The next thing they have asked is you have to find out what is the voltage across the whole circuit V. So you have to find out this first. Now how can I find out this? So you have to find out what is the voltage across the whole circuit. Now, in order to find out the voltage across the whole circuit, what I'll do is I will solve this equivalent, these resistances, that is 20 ohm and 30 ohm in parallel. So I'll find out the equivalent parallel resistance. Then that resistance is in series with 15 ohm. So find out the equivalent series resistance. So in final, what happens is you will be ending up with this type of circuit. That is V. This is the main current I. This remains the same, right? So this is your R equivalent. So R equivalent, how you are going to find out is, 20 ohm and 30 ohm are in parallel. So 20 ohm is in parallel with 30 ohm. This is in series with 15 ohm. So plus 15. So first find out what is 20. So this is 20 into 30 divided by 20 plus 30 plus 15. You will get R equivalent as 27 ohm. So you will end up with this type of circuit. So now can you find out the main voltage? So you can use V is equal to I into R. Now main current they had already given in your problem, that is 3 amps. So main voltage you have to find out. So 3 into 27. This one will give you the main voltage. So 81 volts. So you have already found out the second answer for the second question also. Now third thing they have asked you is you have to find out what is the total power and the power consumed in all the resistances. So first let me find out what is the total power. Now in order to find out the total power, I'll use this equivalent circuit itself, that is this final circuit which I have got by finding out the equivalent resistances. Now you know this equation, that is the power equation, P is equal to V into I. Now V you have already found out here. So 81 into what is the main current is 3. So 81 into 3 will give you the power 243 watts. So next they have asked you to find out what is the power consumed in all the resistances. So you have to find out the power which is consumed in 15 ohm resistor, 20 ohm resistor and 30 ohm resistor. So first let me find out what is the power consumed in the 15 ohm resistor. So how are you going to find out what is the power consumed in the 15 ohm resistor? Now you know P is equal to VI equal to I square R equal to V square by R. Right? So this is your equations for power. Now which equation should I use here? In order to find out the equivalent, in order to find out the power in each of the resistor, which equation should I use? Now if you
I
see here,
square R.
exactly, so I square R. So let me tell you why I can't use this equation. Why? Because you have only the main voltage here. You don't, if you have to use, if you are going to use this equation, what you have to do is you will have to find out what is the this voltage, what is this voltage again. Only then you can use this type of the equation where you have to substitute voltage, or else you can't use. So simple thing is what you can do is you can simply directly use this equation. So P15 is equal to I square R. Now current flowing in 15 ohm resistor is I1. So what is I1? I1 they have already given you directly in the problem. So 3 square into resistor is 15. So 3 square into 15 will give you the power in your 15 ohm resistor. Let me find out what is the power in your 20 ohm resistor. So I2 square into R. So what is I2? I2 you had found out. So I2 was 1.8, right? So 1.8 square into 20. This one will give you the power in the 20 ohm resistor. Next is the power in the 30 ohm resistor. So just a minute. Wait, I mentioned here a little wrong, okay? Power in the 20 ohm resistor, current in the 20 ohm resistor is I1. Whatever I have substituted, that is proper. Just the variable I have written it wrong, okay? Next, P30 ohm. So that is current in the 30 ohm resistor is I2. So I2 square into R. So what is I2? I2 is 1.2. So 1.2 square into 30. Yes. So this is how you are going to use your power equation in the problems whenever they have asked you to find out the power.